Okay, well, first of all, thanks for checking out the video. This is going to be a simple walkthrough of STK10, which is a new version of STK for AGI, and its ability or interoperability with other third-party tools. In this case, I'm going to be demonstrating interoperability between STK and ESRI tools. So if you're unfamiliar, I'll actually bring up an ESRI ARC map window. ESRI creates ArcGIS, which is essentially an industry standard tool for geospatial data. It allows you to build and compile different map documents and layer your data in any way that you see fit. So in this example, we've brought in a couple of data sets into ESRI's ArcMap product. And as you can see, it's just some geospatial data representing some points on the map here. Now, these points are being streamed back to STK. We have a Globe Manager product that allows you to point your ArcGIS map document to stream into STK. So I have the exact same data being shared between both products. So this is great, and this is important for us because this data allows you to compile all of your information, all of your geospatial data into a single tool such as STK, which will allow you to hopefully make better decisions, plan missions, and do a lot of analysis that otherwise you may not be able to do inside of some of the ESRI products. So let me give you a quick example of that. For this particular demonstration, you can see all of these geospatial data points that are being streamed in from our map document. And these are representative of coastal or off-the-shore pirate attacks. So I'm going to focus in on one area. Now, one important thing to realize with STK10 is as I'm zooming in, I'm actually streaming Bing imagery, satellite imagery, onto my 3D globe. This is new in STK10 in the sense that every single user of STK, whether it's our free product or our more advanced paid modules, will have this capability. So this is really exciting for us. This is also working in our 2D window. Our 2D map window has been rebuilt, and there's a lot of changes that were made, particularly for just usability enhancements. So you can see that I can just drag and move the map around. I can use my scroll wheel to zoom in and out. So this is new capability, and it just makes the 2D window a little more useful and a little easier to manipulate. So back to our 3D window, what I've done for this example is I've created a proposed radar facility. And this radar, I'll go ahead and zoom to that. This radar facility has been placed in a specific location. It's just a coastal tentative representation of where I might want to place a coastal radar. So I've placed this radar facility, and what I want to do is see how effective my different radar systems might be in helping to mitigate some of these known pirate attacks. So I can see the areas historically where these are taking place, and I'm proposing to install a radar facility at one of these sites. So this is sort of the beauty of STK, is that I can model my different radar systems. I can trade off antenna types or different system parameters that go into designing that radar, and I can see how effective they are in theater and see how well I'm able to cover this particular area. So I've done this for two different coverage aspects. In the first one, I'm utilizing my specific radar, and I'm looking to see how capable it is at determining or reconciling a probability of detection for a 50 square meter radar cross-section target. So this would be a much smaller boat or shipping vessel. I've also done the same thing for a 1,000 square meter target. So this is a much larger cargo ship. So let's take a look at the 1,000 square meter resolution. As I turn that on, what I can see is that in my 3D window, I'm able to overlay coverage graphics that represent what my probability of detection would be utilizing this particular radar and trying to resolve that particular type of radar cross-section target. Now, you'll notice if I change my view that I've actually brought in some terrain, both visually and analytically, and that terrain is being utilized to help constrain this into a more realistic situation. So I can see the impact of terrain and what that terrain impact has on my radar's ability to detect that 1,000 square meter target. Now, let me trade that out. I'm going to turn my 1,000 square meter resolution off, and I'm going to look at how well we could obtain 50 square meter, and you can see that my my effective probability of detection is quite a bit diminished for that size of radar cross section. So I can really take get a really good idea of how effective that particular radar, the radar that I've chosen to design inside of STK, is at essentially resolving that particular class or that type of target. So this is really useful information. This is great to have inside of STK. The great thing about our interoperability with ESRI is that I can take essentially that exact same data and I can export it back out to a geodatabase. In this case, I'm just turning on that exact same coverage information, except I've overlaid it into ESRI's ArcMap product. So I'm looking at my 50 square meter coverage, and this has just been exported from my STK coverage graphics in the form of a JP2 image file. So it's just an overlay. I also have the flexibility to take each individual area where I've created information on that probability of detection and bring that into ESRI products with just single point information. The nice thing about that is that it's no longer just an imagery overlay, but it's actually individual pieces of information that I can then utilize inside of ESRI products and use some of their geoprocessing tools. But in this case, just for simplicity, I've brought in some JP2 overlays. This is still really useful information, and it's great for sharing and collaboration and helping analysts determine maybe what an entire system of coastal radars is capable of detecting, and seeing how that overlays with other layers of geospatial data. So you can see that we've brought in our 50 square meter and our 1,000 square meter overlays. So I can really do a lot of cool things with interoperability and sharing data between the two. To take this a step further, I've also been able to create a restricted area. So this is just a shapefile that maybe represents an airspace where if I have air assets, I can't really penetrate that particular area target or this area of interest. So I need to make sure that if I have other assets that I'm creating inside of STK, that I'm also not violating that airspace. So let me take a look at that as well. I'm able to share that geospatial data and essentially just bring that data into STK. So I have that exact same shapefile being brought into STK, except I'm using the power of the 3D window to extrude that up to its proper altitude. Now this is important information for me in the event that I may have been also planning some sort of UAV route. So here's essentially just an example route where I've clicked a couple of waypoints. I've let some of STK's more advanced propagation algorithms for aircraft, this is our aircraft mission modeler, essentially create that route for me based on the waypoints that I'm providing. So this is a really cool example of how to share that data back and forth. What I can do with this restricted airspace information inside of STK is I can utilize some of STK's analysis tools. Let me give you an example. So my UAV and my restricted airspace are both being modeled as objects inside of STK. What I can do is go to my access tool for my UAV, and I can determine when I'm going to have access to this restricted air zone. Essentially, when am I going to be inside that restricted airspace? And STK can quickly tell me, based on my route and my geospatial information for my restricted airspace, when I'm going to be violating that based on my route. So I can see windows of opportunity where I'm violating that airspace with my proposed aircraft route. So this is great information. I can look at that in graphs and reports, but I actually want to take advantage of some of the processing tools inside of STK and some of our new features like our time tool to extract those time intervals and use it for extended analysis inside of STK. So what I'm going to do is I'm going to go to the properties of my UAV, and this is going to bring up a properties window that allows me to edit a couple of things. What I'm going to go to is my my 2D graphics attributes page, which allows me to use computed time components in order to show different aspects of my vehicle route. Now, I've already set this up in the sense that I asked STK to calculate access. So I now have an access object. This is my aircraft to my area target access, and as it was computed by STK. It shows up, and I can see that I actually have access intervals as a new time component that I can utilize. If I select that, that allows me to bring this into my my properties of my aircraft, and I can change a couple of things. Let me make this red, and I may want to change the different line styles, what have you. And when I go back to my 3D window, I'll now see that the portions that STK calculated that I was going to be in violation of this restricted area have now colored my aircraft vehicle's flight route red. Well, this is important, just visual information. I can take a look at that in both my 2D and 3D window. I can even take this data and, if I wanted to, export it back out to my ESRI map document. And in this case, I've already done that. I actually went ahead and exported my UAV's aircraft flight route. I've also done a lot of cool things that STK will allow me to do. In this case, my aircraft, I may want to utilize that information to go and replan my route. So I can quickly and easily in the 2D window reposition some of my waypoints, and I'll see that it's now removed any of the red areas within my vehicle route that was there because I was flying inside of this restricted airspace. So just to prove that we're actually calculating a lot of this on the fly, I'll just move this waypoint back inside this area and recalculate that, and you'll see that STK went ahead and recolored my route back to red. That shows me I have an access violation there. So this is really cool capability, and I've been able to plan both radar and UAV ISR mission objectives within one software package. I'm also able to take this data, like the field of view of my sensor on board my UAV. This is all just geospatial data that STK is calculating, and I can take that data and share it as well with my ESRI products. So you've already seen the flight route inside of my map document here. I've also exported my UAV imaging footprints. Now, what we can do is we can take a look at those footprints, and obviously inside of STK it's more of a time dynamic calculation where I've got footprints every so often that are being drawn onto the surface of the Earth. Well, I can also share that information inside of my ESRI map. So now you can see I've activated time on this particular layer of data, and using the ESRI time slider, I can activate time and actually play through an animation that shows me through my simulated STK scenario, sharing that data back to ArcMap and look at that in more of a time dynamic fashion. So this is really great capability, and in my opinion, I think it's a really great example of how open STK is from an architecture standpoint to receive and share data between multiple different products. So anyway, I hope this was helpful, and we'll see you next time. Thanks.